Welcome back, Tech Trailblazers. Today, we're venturing into one of the most exciting frontiers of AI, agent communication protocols. These aren't just back-end specs or dusty standards. They're the digital glue holding together the next generation of AI, autonomous agents that think, talk, and collaborate. Whether you're orchestrating fleets of AI tools, managing robotic workflows, or building LLM-powered assistants, these protocols are mission-critical. If you're a developer, researcher, or AI architect, buckle up, this isn't just theory. This is your blueprint for building scalable, secure, and interoperable agent ecosystems. We're diving deep with domain-specific terminology, architectural diagrams, and real-world protocols used by the likes of Google, Cisco, IBM, and CMU. Let's decode how agents negotiate, delegate, discover, and collaborate, not just to execute tasks, but to cooperate as intelligent systems. Why protocols matter, the problem they solve. Imagine a world where every AI agent speaks a different language. One queries a database, another schedules a meeting, and a third controls a drone, yet none can understand the other. It's chaos. No shared protocol means brittle systems, hard-coded integrations, and zero interoperability. Enter agent communication protocols. These frameworks define how agents talk, the language they use, how messages are structured, and how conversations unfold over time. They go beyond APIs, they're engineered for negotiation, discovery, reasoning, and trust. Think of them as digital diplomacy, mutually agreed rules that make collaboration not just possible, but powerful. Anatomy of an agent protocol. Every protocol boils down to three key layers. Communication language. This is the agent's vocabulary. Rooted in speech act theory, languages like KQML and FIPA-ACL allow agents to say things like inform, request, query, not just exchange data, but express intent. Protocol syntax. Think of this as message grammar: who's speaking, what's being said, when, and why. Serialized in formats like JSON or JSON-LD, it ensures every agent reads and writes in the same structure. Interaction strategies. This governs the flow of conversation. Using finite state machines or UML sequence diagrams, protocols define how dialogues unfold: initiation, proposals, acceptances, fallbacks, enabling intelligent, context-aware exchanges. Together, these layers create systems that are composable, explainable, and resilient, critical in real-world applications. The protocol landscape, a two-dimensional taxonomy. Let's explore this ecosystem by two lenses. Who are agents communicating with? Context versus other agents. Where are they being applied? General purpose versus domain-specific. Context-oriented protocols. These enable agents to connect with external resources, your APIs, databases, and services. General purpose. Model Context Protocol, MCP, by Anthropic. Think of this as an intelligent data adapter. MCP standardizes context fetching via RPC plus OAuth, allowing agents to securely query external systems in a consistent format, ideal for integrating memory, search, or tool APIs. Domain-specific. Agents.json, by Wildcard AI. This protocol is like robots.txt, but for agents. It exposes structured site metadata at /well-known/agents.json, enabling agents to semantically crawl and interact with web content. Interagent protocols. Here's where things get exciting. These protocols let agents talk to each other. General purpose. Agent-to-Agent, A2A, by Google. Agents discover each other's capabilities using agent cards, JSON manifests, then invoke tasks over RPC, complete with auth and state tracking. It's like OAuth for agents, with UX negotiation baked in. Agent Network Protocol, ANP, community-driven. Designed for the open web of agents, ANP uses JSON-LD plus DID for semantic, secure discovery. Think of it as DNS plus Handshake for agents. AITP, Agent Interaction and Transaction Protocol, near foundation. In decentralized systems, trust is key. AITP leverages blockchain-backed DIDs and cryptographic messaging to ensure secure, verifiable agent interactions, ideal for inter-org coordination. ACONP, Agent Connect Protocol, by Cisco/LangChain. Built on OpenAPI 3.0, this protocol lets enterprise systems invoke local agents on internal networks. Think, plug-and-play, orchestration inside your LAN. ACOMP, Agent Communication Protocol, by IBM. Tailored for automation workflows, ACOMP integrates with UI and NLP agents, bridging natural language interfaces with structured execution models. Agora, University of Oxford. A meta-protocol that uses LLMs to dynamically negotiate which protocol to use. Why? Because not all conversations are equal. Agora balances structure, flexibility, and robustness based on interaction frequency and complexity. Agent Protocol, by AI Engineer Foundation. A lightweight, open API-based standard defining agent lifecycles with abstractions like runs, threads, and store. It's gaining traction in open-source agent ecosystems. LMOS, Language Model Operating System, Eclipse Foundation. A full-stack framework for scalable, observable multi-agent systems. Using Web of Things, WAT, standards and DIDs, it ensures secure, real-time interactions across agents and devices. Protocols powering the agentic future. Domain-specific protocols, where AI meets the real world. As agents step out of the lab and into the wild, communication protocols are becoming their universal language. From human interaction to robot swarms, let's explore the groundbreaking work shaping this new frontier. Human-Agent Interaction Protocols. PXP Protocol, BITS Pilani. Imagine talking to an AI that understands your intentions and can explain itself just as clearly. The PXP protocol is built on a finite-state machine and uses intelligent tags like ratify, refute, revise, and reject to manage understanding between humans and large language models. Early trials in radiology and drug discovery show its potential to transform high-stakes decision-making. LOCA Protocol, CMU. In decentralized agent ecosystems, trust isn't optional, it's essential. The LOCA protocol leverages a decentralized ethical coordination protocol, DECP, to ensure agents align with human values. Think of it as a moral compass for autonomous systems. Robot-Agent Interaction Protocols. CrowdES, GIST, South Korea. How do agents coordinate in physical space? CrowdES tackles this by enabling robots and agents to reason spatially, crucial for everything from warehouse automation to disaster response. SPPs, Spatial Population Protocols, University of Liverpool. In swarm robotics, milliseconds matter. SPPs use vectorized queries for fast, reliable coordination across large populations of simple agents. Think drone swarms stabilizing in dynamic environments. System-Agent Interaction Protocols. Protocols like Agent Protocol and Agents.json act as middleware, orchestrating seamless communication between agents and external control systems, databases, or cloud resources. These are the glue behind scalable AI infrastructure. Multi-agent collaboration flow? Picture this. Agent A sends a JSON RPC task request to Agent B. Agent B shares capabilities via an A2A agent card. Agent C hops in using ANP discovery via JSON LD plus DIDs. A blockchain layer, AITP, validates identities in real time, depicted as a cryptographic handshake. This is multi-agent coordination at its finest, fluid, secure, and autonomous. Future horizons. What's next for agent protocols? The protocol landscape is evolving faster than ever. Here's a glimpse into what's coming. Agent mesh protocols. Inspired by mesh networks, these protocols allow dynamic coordination across thousands of agents, forming fluid, adaptive collectives. Agent data networks, ADN. Think of them as the 5G for agents, optimized for ultra-fast, high-throughput communication using protocols like gRPC and MQTT. But here's the catch. For these systems to work at scale, they must be reliable, with built-in fault tolerance and smart retry mechanisms. Secure, with zero-trust architectures and context-aware sanitization. Interoperable, ditching vendor lock-in with open, framework-agnostic standards. Why this should matter to you? Whether you're integrating agents with APIs using MCP or Agents.json, designing human agent UX with PXP or LOCA, building autonomous fleets with CrowdES or SPPs, or orchestrating entire ecosystems with AITP, ANP, or A2A. These protocols aren't just specs, they're your blueprints for building the next generation of resilient, interoperable AI systems. Internet of Agents. Zoom out to a breathtaking view of a living, breathing Internet of Agents, nodes pulsing with data, protocols weaving them together, powering a smart, self-regulating city. Welcome to the next era of autonomy. Ready to dive deeper? Which protocol are you excited about? Let's geek out in the comments. If this sparked new ideas, like, subscribe, and hit the bell for more deep dives into agentic AI. Until next time, keep architecting